All right, well, cohort A. I just want to tell you, I had so much fun with cohort B today. I don't know, I think they're kind of more fun than cohort A. Kind of getting that feeling like one kid was kind of like, did her hair like a water molecule. I thought that was really like scientific. Anyway, so, uh, yeah, so you guys are at home. And I'm sorry this one took so long. It's a little bit hard for me to record them at night sometimes. So I'm in my classroom doing this right now. And listen, this lesson's pretty short today, and I know you don't believe me, okay, because like they've been quite long. Look, if you find the lessons really long, and I know that they're really riveting and exciting and everything, but the online lessons, I mean, what I need you to do is, if you're finding it long, you're getting tired and you're losing your focus or whatever, just pause the video. You can always read the book too. Mix it up a little bit. Fast forward to the spots where you think you need the most help. That kind of thing. You can sort of just move along and see, oh, here's where it explains tides. I'll just go to that spot. Like that kind of thing. So like you have control, right? When you're just watching a video. So use that control to manage yourself, okay? How you want the lesson to go. All right, this one's kind of short, but it's actually really important. And at first, it might sound like we're not talking about space, but in fact, we are. Okay? So, here's the deal. We need to talk about how things are measured, okay, in science class in general. And I don't just mean for the space unit. I mean for the whole course. And also for your future. So that means when we're talking about other units, like when we do electricity or when we do chemistry, we're always making like measurements in science. So I need your numeracy to be really good, and that starts with understanding the metric system. You'd be surprised at how many people don't really get it. Okay, so first I'm going to start with something familiar, and then I'm going to show you how powers of 10 work. And that this is, I know you've learned this, I gather from cohort B, that today that you know this, or at least you know how to do powers in math class, okay? I wonder if I should use a microphone. Here, does this help? Okay, so here's the deal. What I'm going to do is I'm going to zoom into the margin here. We'll talk about this chart in a moment. But before we do the chart, we're going to talk about math, how you do certain powers of 10. Okay, so it goes like this. Do you know what this means? Okay, this is 10 to the power of 2. 10 to the power of 2 means 10 times 10, which is equal to 100. Good, right? Got it. What about 10 to the power of 3? Well, that's 10 times 10 times 10. 3 powers of 10 make 1,000. Okay? In science, powers of 10 are really important. We use them all the time. Okay? So that's how powers work, right? So that's called an exponent, the 3 and the 2, and the base is 10, okay? All right, do you know what 10 to the power of 1 is? Well, that's just 10, of course. What about 10 to the power of 0? Okay, this one's kind of confusing. A lot of people will write 0. That's incorrect. It's actually not 0. What it is 1. Any number to the power of 0 is 1 except the number 0. So 0 to the power of 0 is undefined for reasons I can explain later. All right, what about this one? 10 to the power of negative 1. For reasons I'll explain in a moment, that's 1 over 10. Okay? 10 to the power of negative 2 would be 1 over 10 squared, which is equal to 1 over 100. Okay, so it becomes, we call it reciprocal. When you have a negative exponent, you get what's called a reciprocal number. So reciprocal means when you take sort of the fraction, you turn it upside down. Now, why is it like this? Okay. Now, the students this morning, I explained it to them quickly. Let me show you how you do division with exponents. And the reason why I'm doing this is to explain to you why a number to the 0 is 1, and the negative exponent is 1 over. Okay, let me explain it. So let's say I had 10 to the power of 5 divided by 10 to the power of 2. Okay, so I'm dividing. Well, I'm just going to expand my exponents. 10 times 10 times 10 times 10. It's 10 times 10 times 10 times 10 times 10, right? That's 10 to the power of 5. Well, 10 to the power of 2 is just 10 times 10. So this becomes that, becomes this. Now you can divide. 10 divided by 10 is just 1. Okay? This 10 divided by that 10 is another 1. Whenever you divide a number by itself, the answer is 1, right? Now that leaves me with these numbers here at the top that have not been divided by a power of 10 on the bottom. And so the answer is 10 times 10 times 10, just divided by 1, because whenever I cancel out a 10, I get a 1 left over. I don't have to write the 1s. So that's just 10 to the power of 3. Now, if you know the rule, you can go straight to it. If I have 10 to the power of 5 divided by 10 to the power of 2, notice that 5 minus 2 is equal to 3. Okay? Now, today we did this in class. I can't do it interactively with you, but let's say I did it like this. Let's say I had 10 to the power of 25 divided by 10 to the power of 6. Okay? I don't want to write out 25 tenths there. Okay? So what I do instead is I just use the rule. The answer will be 10 to the power of 25 minus 6. Because like those 6 on the bottom are going to cancel out with 6 on the top. And I end up with 10 to the power of 19. And again, I'm not going to expand it to write out all the zeros. Okay, so it's 10 to the power of 19. And that's the rule for subtracting, like the rule for dividing exponent powers with the same base. Okay, you subtract the exponents. Now, what would happen using this rule if you had more on the bottom than on the top? Like what if we had 10 to the power of 3 divided by 10 to the power of 7? Okay? Well, we can still use the rule, but before we do that, let's just remind ourselves how it works. That's 10 to the power of 3 on the top. On the bottom, we have 7 of these. That's 7 of them there. Well, this one's going to cancel with that one, leaving a 1. That's going to cancel with this one, leaving a 1. That's going to cancel with this one, leaving a 1. Okay, you always get a 1 left over. And I'm left with, on the bottom, 4 powers of 10. So what I get is this is equal to 1. I don't have 0 on top. I have a 1 on top. 1 times 1 times 1 is 1. But then that 1 is going to be divided by 10 to the power of 4. Okay? Now, if I use my rule for subtracting exponents, 10 to the 3 minus 7 would equal what I wrote on the right side over here. But 3 minus 7 is negative 4. So that's 1 over 10 to the 4. Remember I was telling you that if you have a negative exponent, it's reciprocal? Well, I hope this example shows you why. Okay? And that's it. Now, that's how you do powers of 10. Oh, and by the way, what about 10 to the power of 0? Why is that 1? Well, what if I had 10 to the power of 5 divided by 10 to the power of 5? What do I get? Well, the rule tells me to subtract the numbers. Well, what's 5 take away 5? Well, of course, that's 0. But if I just do any number divided by itself, of course, is 1. And so when I cancel all the numbers on top with all the numbers on the bottom, I'm not left with 0. I'm left with 1. Okay? And that's how powers work. Okay? And exponents. So now that you have some sense on how to do this, let's look at the metric system. Okay? So now what I did over here in the margins is I wrote units of measure for you. So distance, the standard unit for measuring distance is meters. Okay, so a meter stick is a 3.3 feet approximately. Okay, so if someone was 2 meters tall, that'd be like a basketball player because they'd be over 6'6" for sure. I think guy who plays Thor, Chris Hemsworth or whatever, I think he's 6'4" or something. He's 185 centimeters, so he's short of 2 meters by quite a bit there, but he's a very tall guy, so it gives you a sense of what a meter is. Anyway, mass. Mass is how much matter is in something, and that's measured in grams. Volume, okay, is measured in, there's a couple of options for volume. We either use liters, like a liter of milk. That's how much space it takes up, is a liter. Or we use cubic meters for something like a pool, or an ocean or something like that, where it's a very large quantity of water. Energy is measured after a guy named James Joule, so joules for energy. Power is measured in watts. It's actually named after a scientist also. So it's joules. Power is the rate that you're using energy, so it's in joules per second, and a joule per second is a watt. Okay, speed is measured in meters per second. Seconds are a standard unit for time, right? And sometimes we use kilometers per hour, and I just said that 1 meter per second is actually 3.6 kilometers per hour, just for interest's sake. Okay. Anyway, so that takes care of the units of measure, but what I need you to do in this little activity is you need to be able to convert from different units of measure. Okay, so let me explain. Let me erase this. Okay, I think most of you know what kilo means, so I'm going to start with that one. Like a kilometer, or a kilometer, or however you want to pronounce it, that prefix kilo means 1,000. So most people will remember that there's 1,000 meters in a kilometer. Well, how many grams are there in a kilogram? And of course the answer is 1,000, right? How about how many bytes are in a kilobyte? And the answer is also 1,000. Okay, so kilo is a standard way of saying 1,000 of something. Okay, if that makes sense to you. So that's why a kilometer is 1,000 meters, and a kilowatt is 1,000 watts, a kilojoule is 1,000 joules, and so on. Okay, so with that in mind, that's what kilo means. And if you look what I wrote under here, that number 10 to the power of 3 is 1,000. Okay, now I hope that makes sense to you. 10 times 10 times 10 is 1,000. Okay, so that kilo means 1,000, and that's why I wrote it here. Now let me explain some of the other ones. Mega, now you own a phone, sometimes we measure memory in megabytes. Okay, when I was a kid, I had a Commodore 64 computer that had 64 kilobytes of memory. Okay, and that's why they call it the Commodore 64. And believe it or not, that was considered a lot. 64 kilobytes of memory. It's not even enough for one picture on your phone. Okay, not even close. But back then, before digital photography and video and all this other stuff, that was a lot of memory, believe it or not. All right, that was kilo. Mega means a million. So 10 to the power of 6 means million. You have a million of something. And a million is 1,000 times 1,000. Like, so it's 3 powers of 10 bigger than a kilo, right? So anyway, 10 to the power of 6, that's 1 million. 1 with 6 zeros after it is a million, right? Mega means million. And we use a capital M, okay, to represent mega, where a K, small k, represents kilo. Okay? Now a capital G represents this unit called giga, and the memory on your phone is now measured in gigabytes. Okay? And 1 gigabyte would have actually 1,000,000 kilobytes in it. Okay? 1,000,000 kilobytes. So I had a Commodore 64 that had 64 kilobytes of memory, just 64. 1 gigabyte is 1,000,000 kilobytes. Okay, so it just gives you some sense of how much the technology has come along since then. All right, giga means a billion. So, it's 1,000 million. Okay, now if you look, there's a little pattern here. You're going up by 3 powers of 10 as you move along here like this. But then after that, it's 1 power of 10. So here there's 3 here and a 3 there. So, 10 to the 3 to get to 10 to the 6, there's 3 more powers of 10. But moving here, there's only 1. Here, there's only 1. Okay? From here to here, there's only 1, and then here there's 1, 1, 1, and then 3, and then 3. So we like to skip by 3 very often, but sometimes we use intervals of 1, okay? 1 power of 10, that is. Now, I tell students, you don't have to memorize the chart. I will give you the chart. We're gonna have a quiz on this, okay? I'm gonna give you the chart, so don't stress about it, but you have to be able to use it to do the questions, okay? So that's your job, is to understand how to do the questions that are based on this chart. Okay, so, by the way, hecta means 100, deca means 10, okay? Deci means 1/10, okay? Centi means 1/100th, milli is 1/1000th. Micro, we use a special letter. It's the Greek letter mu. I often draw it like this. We run out of m's. We use little m for milli, big M for mega. So micro, we use a different letter. It's a Greek letter called mu. And that's the letter we use to represent micro in science, okay? So a micron is really small. A micrometer would be like, you know, there might be 10 microns. Your hair, like a strand of your hair, might be like 50 microns across, okay? Anyway, the coronavirus, how big is a virus? Well, it's nanometers. It's way smaller. You can't even see it with an optical microscope. You'd have to have an electron microscope to see them. They're incredibly small. Viruses, that's how it took so long for us to discover they were even there. But yeah, nano means a billionth. So imagine taking a meter stick and slicing it in a billion equally sized pieces. 1 nanometer would be the size of one of those pieces, a billionth of a meter. All right, so now that you know what all the symbols mean, and you know what power of 10 they each represent, okay, these powers of 10 that I wrote here, what I'd like you to do in the activity below is convert from one unit into another one, okay? So let's do one of these together, and what I'm going to do is I'm going to zoom in a little more, okay, so that's easier for me on the smartboard and maybe easier for you to see. Okay, so it says use the chart to correctly complete the following metric conversions. So we're just converting from one unit into another one. So here in the first one, we're converting from kilometers to the base unit. This is base. Base is right there, and it is 1. You know what I mean? 1 unit. So here where it says 125, where's the decimal place? That's what I ask the students in class, and they know when you don't see a decimal, it's at the end of the number. It's good to know where the decimal is, okay? Now, you look at kilo. Kilo represents 10 to the power 3. So I'm going to use a pen here, a red pen. That's where we are in question A. Okay, we're at kilo, and we're going to move to the base unit. So we're going to go from there to there. Now, how many powers of 10 is that? Well, it says right underneath, it's 1, 2, 3. Kilo means 1,000. That's 3 powers of 10. So to get to the base unit, I'm going to have to move my decimal 3 places to the right. And when there's no number there, I have to add zeros. So watch, I'm going to go like this. I'm going to write 125, and then I'm moving the decimal 1, 2, 3 places. I'm going to put 0, 0, 0. Now the decimal's over here. So my answer is 125,000. Okay? That should make sense to you, that 120, if 1 kilometer is 1,000, then 125 should be 125,000, right? So that's it. Next, can you go the other way? Can you convert grams, okay, grams, into kilograms? Okay, so here, this time we're starting at base. Okay, we're starting with the base unit, and we are going over to kilograms. So this time, I'll use my red pen again. We're starting at the base, and we're going over to kilo in the opposite direction. So this time, instead of moving the decimal to the right, we're going to move it to the left. So here we are, here's our decimal. We're going to move it 1, 2, 3 places to the left, okay? And that will leave us with 1.245 kilograms. Good, right? That's how you convert metric units. Okay, I'm going to let you do the rest of that. Okay, I'm going to see if you can do the conversions on your own, and we'll take this up and correct it. We're going to have a quiz on this. Okay, so please make sure you get it. Okay, next, I've got one more thing for you, and then the lesson's over. Scientific notation. This one won't take me very long to explain. I already did some of these with the students, so let me erase it and do it with you. Okay. The rule in scientific notation is this. You're going to write a number with a power of 10 next to it. Okay, that's how you write numbers in scientific notation. We use this for writing very large and very small numbers, but there's just a couple of rules that you have to remember. Okay, and one of the rules is you can only have one digit that's not 0 in front of the decimal. Okay, so let me explain. Here's a number written in standard form. Okay, it's actually a really small number. It's only 6 micro, like it's in the micro range. So I need to write this number in scientific notation. I'm going to move the decimal 1, 2, 3, 4, 5, 6, so that there's one number that's not 0 in front of it. In this case, there's only one number that's not 0. So I need to move the decimal place 6 places over. So I'm going to write this is equal to 6. Okay. Now I have to, in order to tell you how small that number is, I'm going to write a power of 10 next to it. Well, I moved the decimal 6 places, and therefore I have to write 10 to the negative 6, because it was 6 places to the right that I moved it. Right means it's negative, okay? And that's how you take a number in standard notation and you write it in scientific notation. So that one is the scientific notation, okay? Let's do another one. All right, yeah, let's do this one. Oops, sorry, okay. All right, so here, 5.4 million, okay? Or 5,400,000, that's what that number is. All right, so when you don't see a decimal, it's right there. I'm only allowed to have one digit in front of the decimal and it can't be 0. So I'm going to move my decimal place 1, 2, 3, 4, 5, 6 places. So I went 6 places this way, okay? 6 places. So in other words, it's left 6 places. Now I'm going to write my answer. It's going to be 5.4 because I left the 5 in front of the decimal. And then I'm going to write times 10, this time not to the negative 6. Because I went to the left, it's going to be positive 6. Okay? And that's how you write numbers in scientific notation. It's really quite easy. Now I did another one for you here. So let's do one more. So I'm doing some of your homework for you. I'm sure you appreciate that. Here's my decimal. I have to move it 1, 2, 3 places to move it over there. So this is equal to 9 times 10 to the negative 3 because I moved 3 places to the right. Okay? If it's right, it means negative exponent. If it's left, it means positive exponent. That's it. Okay? Let me point something out to you here. This one looks like it's in scientific notation already. It's not, because the decimal is right there, and the rule is you're only allowed having one digit in front of the decimal, not 2. So we have to move the decimal 1 place to fix it. So this is equal to 7.1. Actually, I'll write it next to it here. 7.1 like this. Now, it was already times 10 to the 3, but I moved it 1 more place to the left. So I moved it this way 1 place. So I have to multiply it by 10 to the 1, but I'm going to add that to the 3 powers of 10 that are already there. So I have to add 1 to this. 3 plus 1 is 4, so it's going to be times 10 to the 4. Well, guys, that's it. Okay, that's how you write numbers in scientific notation. Now, the other thing you have to do is you have to be able to go the other way. So I'm going to just go turn the page here. Okay, so you'll find these sheets in OneNote. I'll push them, if you like, into your individual homework folders, okay, or homework pages, and you can look at it there. But anyway, take a look at this. Can you go the other way? Can you take a number that's written as a power of 10 and change it so it's just in standard notation, which means just written like a regular number? And it's actually really easy to do this, okay? This means when you already have the power of 10 and you want to write it as a decimal, this means you're going to move the decimal in that direction. Actually, sorry, I got it the wrong way. You're going to move it in this direction. So you move it this time to the left. If it's a negative, you have to do the opposite of what we did last time. So you're going to move it to the left. So this one's going to be 0. Here, if I move it one place like this, it's going to be 0.09, pardon me if I didn't say it right, and that's the answer, okay? So I'm going to move it one place, because it's 1 power of 10, one place to the left. Now, if it's like this, I have to move it that way 5 places, okay? So if it's a positive power of 10, you move it that way. So I'm going to write 2. My decimal was here, so I'm going to go 1, 2, 3, 4, 5. So then I have to add zeros as my placeholders. So that's 200,000. Now I know I wrote it already here. Let me erase that. And guys, that's the end of the lesson. So that took 26 minutes. That's a lot less. It's like normally one lesson is like 40 minutes, and so 2 makes an hour and a half almost. So this is just 26 minutes, and all you have to do is finish those 2 worksheets per part of the homework. We're going to review for a test early next week, and that'll be our next thing that we do when you come in tomorrow. So please try this for homework, and then we'll see you tomorrow. All right, guys, have a good day. We'll talk to you soon.